Quantum mechanics. Just hearing the term might make you think of mind-bending equations and paradoxes. But what if I told you that quantum mechanics is less about complex math and more about understanding the strange and beautiful rules governing our universe at its tiniest levels? Today, we're going to break down three key concepts: quantum entanglement, superposition, and their real-world applications in a way that's easy to grasp. What is quantum mechanics? At its core, quantum mechanics is the branch of physics that describes how the universe behaves at the smallest scales. Think atoms and particles even smaller than atoms. At this level, the classical rules of physics, like Newton's laws, no longer apply. Instead, particles behave in ways that seem illogical, unpredictable, and even magical. For instance, did you know that a single particle can exist in multiple states at once? Or that two particles can influence each other instantly, no matter how far apart they are? These aren't just thought experiments, they're real phenomena that have been observed time and again. Understanding superposition. Let's start with superposition, one of the fundamental principles of quantum mechanics. Imagine you have a coin. Normally, it's either heads or tails, right? But in the quantum world, it's as if the coin is in a state of being both heads and tails at the same time, until you look at it. This is superposition, the ability of a quantum particle to exist in multiple states simultaneously. The famous example is Schrödinger's cat, a thought experiment where a cat in a box is both alive and dead until someone opens the box and observes it. In real life, this concept isn't about cats, but rather electrons, photons, and other tiny particles. Superposition is what makes quantum computing possible. Instead of using bits that are either 0 or 1, quantum computers use qubits, which can be 0, 1, or both at the same time. This allows them to perform calculations at speeds unimaginable with classical computers. The enigma of quantum entanglement. Now let's move to quantum entanglement, often called spooky action at a distance. This is where things get even stranger. Imagine two particles that become entangled during their creation. No matter how far apart they move, be it a few meters or light years, changing the state of one particle instantly changes the state of the other. Albert Einstein famously didn't like this idea and called it spooky. He believed nothing could travel faster than the speed of light, yet entanglement seems to defy this principle. But numerous experiments have proven that entanglement is real. Why does this happen? The truth is, we don't fully know. Quantum entanglement is one of the great mysteries of physics, but it's also incredibly useful. It's the foundation for quantum communication and cryptography. Imagine a communication system that's virtually unhackable because any attempt to eavesdrop would immediately break the entanglement and reveal the intrusion. That's the power of quantum entanglement. Real-world applications of quantum mechanics. So, how does this bizarre science affect our everyday lives? Surprisingly, quantum mechanics isn't just theoretical, it's practical and essential to modern technology. Quantum computing. As mentioned earlier, superposition and entanglement are the backbone of quantum computers. These machines have the potential to revolutionize industries like medicine, finance, and artificial intelligence by solving problems that would take classical computers thousands of years. GPS and telecommunications. Quantum mechanics enables technologies like atomic clocks, which are critical for GPS accuracy and synchronization in communication networks. Medical imaging. MRI machines rely on quantum mechanics to provide detailed images of the human body. Without quantum principles, this life-saving technology wouldn't exist. Quantum cryptography. Using entanglement, scientists are developing ultra-secure communication systems that could prevent hacking entirely. Even technologies we take for granted, like lasers and semiconductors, owe their existence to quantum mechanics. Why quantum mechanics matters. Quantum mechanics isn't just a subject for scientists and labs. It challenges us to rethink what we know about reality. It suggests that the universe is far stranger and more interconnected than we ever imagined. It's a reminder that science often raises more questions than it answers, and that's a good thing. As researchers continue to explore this field, we're likely to see even more groundbreaking discoveries and applications. Who knows? The next big leap in technology or understanding may come from someone inspired by these very concepts. In conclusion, quantum mechanics may seem intimidating, but at its heart, it's a story of curiosity and discovery. It shows us that the universe operates on rules both mysterious and fascinating. By understanding concepts like superposition and entanglement, we not only unlock new technologies, but also gain a deeper appreciation for the complexity of existence itself. So, the next time you hear about quantum mechanics, don't be overwhelmed. Instead, marvel at the incredible strangeness of the universe and what it can teach us about our place in it. After all, the world of quantum is just beginning to reveal its secrets.